In this lesson, we're going to explore one of the most important resources in application security, the Common Weakness Enumeration, or CWE, which is maintained by MITRE. If you've spent any time researching security vulnerabilities, you've probably come across terms like CWE-79 and wondered what those numbers mean. By the end of this lecture, you'll understand what CWEs are and know how to read and interpret CWE entries. And you'll also understand how they differ from CVEs. This knowledge is fundamental for anyone working in cybersecurity, whether you're a security analyst, penetration tester, developer, or security engineer. CWEs provide a common language for discussing security weaknesses, and they're referenced in security tools, vulnerability reports, and security standards worldwide. Let's start by understanding the organization behind CWE, MITRE. MITRE is a not-for-profit organization that operates federally funded research and development centers in the United States. MITRE has become one of the most important contributors to cybersecurity standardization and knowledge sharing. MITRE was established in 1958, originally focusing on systems engineering and technology development. Over the decades, they've expanded their work into numerous domains, but for our purpose, what's important is their cybersecurity work. MITRE manages several critical cybersecurity resources that you'll encounter throughout your career. There's CVE, which stands for Common Vulnerabilities and Exposures. This is a database of publicly disclosed security vulnerabilities in specific software products. We'll compare this to CWE later in this lesson. Second, there's CWE, Common Weakness Enumeration, which is our focus of this lesson. It's a comprehensive catalog of software and hardware weakness types. And there is the attack framework, which stands for adversarial tactics, techniques, and common knowledge. This is a knowledge base of adversary behavior and attack patterns. If you're interested in threat intelligence or penetration testing, attack is absolutely essential. And there's CAPEC, the Common Attack Pattern Enumeration and Classification, which describes common attack patterns used by adversaries. All of these resources are freely available to the public and are widely used across the cybersecurity industry. MITRE's work is funded by the U.S. government but serves the global cybersecurity community. The key thing to understand is that MITRE provides standardized, vendor-neutral frameworks and taxonomies that allow security professionals worldwide to speak the same language when discussing security issues. Now let's dive into CWE specifically. CWE, or Common Weakness Enumeration, is a community-developed list of common software and hardware security weaknesses. Think of it as a comprehensive dictionary or catalog of the types of security flaws that can exist in software and systems. So let's clarify weakness versus vulnerability. It's an important distinction. A weakness is a type of flaw or condition in software, hardware, or firmware that could, under the right circumstances, contribute to the introduction of a vulnerability. It's a category or class of problem. For example, SQL injection is a type of weakness. A vulnerability is a specific instance of a weakness in a particular product or system. For example, the login form in WordPress 5.2 is vulnerable to SQL injection. That is a specific vulnerability. So CWE catalogs the types of problems that can exist, not specific instances of those problems in particular products. The CWE list was first launched in 2006 and has evolved significantly since then. As of 2025, there are over 900 different CWE entries, covering everything from simple input validation errors to complex cryptographic weaknesses to business logic flaws. There are several important reasons that CWE exists. First, standardization. Before CWE, different organizations, tools, and researchers use different terminology to describe the same type of security problems. One tool might call something SQL injection, another might call it SQL command injection, another might call it improper neutralization of SQL commands. CWE provides a standard identifier and name for each weakness type so everyone can communicate clearly. Second, education and awareness. CWE serves as an educational resource, helping developers, security professionals, and students understand different types of security weaknesses, how they occur, and how to prevent them. Third, tool integration. Security testing tools like static analysis tools, dynamic testing tools, and software composition analysis tools reference CWE IDs in their findings. This makes it easier to understand what type of problem was found, regardless of which tool found it. Fourth, metrics and measurement. Organizations can track which type of weaknesses are most common in their code, measure improvements over time, and prioritize security training based on CWE categories. And fifth, mapping and correlation. CWE provides mappings to various security standards and frameworks like OWASP Top 10, SANS Top 25, and various compliance requirements. This helps organizations understand how different security guidance relates to specific weakness types. CWEs are organized in a hierarchical structure with high-level categories that break down into more specific weakness types. For example, there's a high-level category for input validation issues, which includes more specific weaknesses like SQL injection, cross-site scripting, command injection, and many others. Each CWE entry has a unique identifier, a descriptive name, and comprehensive documentation about the weakness. So we want to learn how to actually read and interpret a CWE entry. So we'll navigate to a specific CWE entry so you can see what information is available. Let's use CWE-294 as our example, which you can find at 294.html, as you can see on the screen. This is authentication bypass by capture replay. When you open a CWE page, you'll notice it's quite comprehensive. There are key sections you'll find. You've got the header information. At the very top, you see the CWE identifier and name. In this case, it's CWE-294, Authentication Bypass by Capture Replay. This is how you'll reference this weakness in reports, documentation, and conversations with other security professionals. You will also see the weakness abstraction level. CWE entries can be class, very abstract, high-level weakness types, base, more specific, typically independent of any particular language or technology, variant, a specific type of weakness tied to a particular technology or context, and compound, meaningful combinations of other weaknesses. CWE 294 is labeled as base level, meaning it describes a fairly specific type of problem, but isn't tied to a particular technology. The description section provides a clear, concise explanation of what the weakness is. For CWE 294, it explains that this is when a product allows authentication bypass through capture replay attacks, where an attacker intercepts valid authentication credentials or tokens and reuses them later to gain unauthorized access. This section gives you the fundamental understanding of what the weakness is about. Then you have the extended description, which provides additional context and explanation. This section often includes details about how the weakness occurs, common scenarios, and why it's problematic. Not all CWE entries have an extended description, but when they do, it's valuable for deeper understanding. There is the relationship section as you scroll down the page, and that's crucial for understanding how this weakness relates to other weaknesses in the CWE hierarchy. You'll see child of, showing parent categories that this weakness falls under. Peer of, related weaknesses at a similar level, can precede, meaning weaknesses that this one might lead to, and required by, weaknesses that depend on this weakness existing. For CWE 294, you might see it's a child of CWE 287, improper authentication, and related to other authentication weaknesses. This helps you understand the broader context and explore related security issues. The applicable platforms section tells you what languages, operating systems, architectures, or technologies this weakness typically affects. frameworks. Some weaknesses apply to any technology, while others are specific to certain programming languages or platforms. For authentication issues like CWE 294, you'll typically see it listed as language independent because capture replay attacks can occur regardless of what programming language is used. You have the common consequences section. This section describes what can happen if this weakness is exploited. It's typically organized by security properties that are violated: confidentiality, unauthorized access to information; integrity, unauthorized modification of data or system behavior; availability, denial of service or resource exhaustion; access control, bypassing security restrictions; authentication, impersonating legitimate users; authorization, gaining elevated privileges. For CWE 294, the common consequence is gaining unauthorized access by bypassing authentication, which affects authentication and access control. And the likelihood of exploit. Some CWE entries include information about how likely this weakness is to be exploited. This helps you understand which weaknesses are more urgent to address. And you can see on this one, it says high. The demonstrative examples section shows up in some CWEs and can be extremely valuable. It provides concrete code examples showing how the weakness manifests in real software. These examples usually include both vulnerable code and often suggested fixes. Sometimes you'll see observed examples. In 294, you see a selected observed examples section. It references real-world CVEs, specific vulnerabilities that are instances of this weakness type. This shows you that this isn't just a theoretical problem, but something that has actually occurred in real software. For example, you might see references to specific products that were vulnerable to the weakness in question, with their CVE identifiers listed, and the potential mitigations section. It's a very practical part of the CWE entry. This section provides guidance on how to prevent or mitigate this weakness. Mitigations are often organized by phases of the software development lifecycle: architecture and design, high-level design decisions, implementation, coding practices, testing, verification approaches, operation, runtime protections, and configurations. For CWE 294, mitigations would include implementing time-stamped tokens, using nonces, number used once, implementing session timeouts, and using secure communication channels. You might see a detection methods section that describes ways to detect whether this weakness exists in your software, including automated static analyses, dynamic analyses, manual code review, penetration testing, and fuzzing. Different weaknesses require different detection approaches, and that section guides you on more effective methods. The membership section shows which CWE lists, views, or categories include this weakness. This is important because several well-known lists use CWE as their foundation. CWE Top 25, the most dangerous software weaknesses; OWASP Top 10 mappings, how this relates to OWASP's list; SANS Top 25, another influential ranking. If a weakness appears in these lists, it's considered particularly important to address. Taxonomy mappings. This section shows how the CWE relates to other security frameworks and standards. You might see mappings to OWASP categories, to WASC Web Application Security Consortium threat classification, to CERT CERT Secure Coding Standards, or other security taxonomies. This helps you understand how this weakness relates to other security guidance you might be following. And then you have the references section. It provides links to external resources, papers, articles, and documentation that provide additional information about this weakness type. These can be very valuable for deeper research. Some CWE entries also include a notes section with additional important information, clarifications, or terminology explanations that don't fit in other sections. The key to effectively using CWE is not to try to memorize all these entries. Instead, you should understand how to navigate and interpret CWE pages. Know that CWE exists as a reference when you encounter a weakness. Use CWE IDs to communicate clearly about security issues and explore the relationships and mappings to understand how weaknesses relate to each other. When you're reviewing security tool output, reading vulnerability reports, or researching a type of security issue, looking up the CWE provides comprehensive, standardized information about that weakness type. Now that you understand what CWE is, let's clarify a common point of confusion. The difference between CWE and CVE. Both are maintained by MITRE. Both use similar identifier formats, and both relate to security, but they serve very different purposes. CVE is the Common Vulnerabilities and Exposures. It's a database of specific security vulnerabilities in specific products. Each CVE entry represents a unique identified vulnerability that has been publicly disclosed. For example, CVE 2023-12345 might be a specific SQL injection vulnerability in WordPress version 6.2. CVE 2024-67890 might be a specific buffer overflow in OpenSSL version 3.0.7. That's just examples of what they could be when you're looking at various CVEs. A CVE identifier is assigned to a specific instance of a security problem in a particular product or code base. It includes information about which versions are affected, severity scores, and often links to patches or workarounds. As we've discussed, CWE catalyzes types of weaknesses. It's describing categories or classes of security problems, not specific instances. The relationship between CWE and CVE is great to understand. CVEs are often mapped to CWEs. A CVE describes a specific vulnerability, and it will reference one or more CWE identifiers to explain what type of weakness it is. So a CVE entry might say SQL injection in WordPress login form, and then the associated CWE, the weakness associated with that vulnerability. That tells you the CVE specific vulnerability identifier, what it affects, what products it affects, what specific versions of those products, what type of vulnerability it is, and what type of weakness it is. So if we think about it this way, CWE is like a medical textbook describing different diseases and conditions. Influenza would be a type of illness with certain characteristics, symptoms, and treatments. CVE is like the medical record of a specific patient. So John Smith contracted influenza on January 15th, 2024. It's a specific instance of that illness affecting a particular person at a particular time. So you use CWE when you're discussing types of security problems in general terms, when you're categorizing findings from security tools, when you're training developers on classes of vulnerabilities to avoid, when you're tracking what type of weaknesses are most common in your organization, and when you're standardizing how your team talks about security issues. You use CVE when you're tracking specific vulnerabilities that need patching, when you're assessing whether your systems are affected by a disclosed vulnerability, when you're prioritizing vulnerability remediation, when you're reporting on specific security incidents, and when you're maintaining vulnerability management processes. And a lot of the security tools that track your environment, you can use the CVE in those tools, and you can say, has this CVE been found in my environment? So CWE is education, categorization, and standardization. CVE is tracking, patching, and vulnerability management. CWEs are relatively stable types of weaknesses. CVEs are new entries published constantly as vulnerabilities are discovered. CWEs are referenced by security tools, standards, and training materials. CVEs are referenced in patches, security advisories, and vulnerability scanners. So they both work together as part of your comprehensive approach to security. Developers learn about CWE types to write more secure code. Security tools detect weaknesses and map them to CWE categories. When specific vulnerabilities are found, they're assigned CVE identifiers. The CVE entry references the CWE to explain what type of weakness is being used, exploited, involved. Organizations use CVEs to track what needs patching. Organizations use CWEs to understand their security posture and improve over time. When you're working with security scanning tools, you'll often see both, telling you what type of problem it is, CWE, and providing context about similar real-world vulnerabilities, CVE. Let's talk a little bit more about how you'll actually use CWE in your cybersecurity work. For security analysts, when you receive vulnerability reports from scanning tools, they'll often include CWE identifiers. Use these to understand the category of weakness, research best practices for remediation, and communicate clearly with development teams about what needs to be fixed. For developers, when writing code or conducting code reviews, familiarize yourself with the most common CWEs relevant to your technology stack. Many development frameworks and security training programs are organized around CWE categories. Understanding that CWE 89 is potentially SQL injection, or CWE 79 might be XSS, cross-site scripting. Understanding these common weaknesses will make you a more security-conscious developer. For penetration testers, when you discover vulnerabilities during testing, reference the appropriate CWE in your reports. This provides your client with standardized information they could use to research remediation approaches and track trends in their security posture. For security tool users, whether you're using SAST tools, DAST tools, SCA tools, or other security testing solutions, these tools will output CWE identifiers. Understanding how to interpret these will help you prioritize findings, filter out false positives, and take appropriate action. For compliance and audit, many security standards and regulations reference CWE. For example, PCI DSS references specific CWE categories that must be addressed. Understanding CWE helps you demonstrate compliance and prepare for audits. Before we wrap up, let's talk about some valuable CWE resources. CWE Top 25 is published annually. This is a list of the most dangerous and common software weaknesses. You can find it at cwe.mitre.org/Top 25. It's an excellent starting point for prioritizing which weakness types to focus on. CWE Views. CWE provides different views or perspectives on weaknesses. There's the development view, organized by development concepts, the research view, organized for security researchers, the hardware view, specific to hardware weaknesses, and the architectural concepts view, and CWE categories. These are high-level groupings of related weaknesses, such as input validation issues, authentication problems, cryptographic weaknesses, and resource management errors. OWASP Top 10 mapping. You can find mappings in the OWASP Top 10, which CWEs relate to each OWASP category. All of these resources are freely available on the CWE website, and I encourage you to explore them as you continue your cybersecurity education. Understanding CWE is fundamental to working effectively in cybersecurity. It provides a common language for discussing security weaknesses, helps you understand security tool output, enables clear communication between security and development teams, and serves as an educational resource throughout your career. Remember that you do not need to memorize hundreds of CWE identifiers. You might get overwhelmed by that thought. What's important is understanding that CWE exists as a standardized reference, how to read and interpret CWE entries, and the difference between CWE, types of weaknesses, and CVE, specific vulnerabilities, and how to use CWE in your daily security work. The CWE website at cwe.mitre.org should be bookmarked in your browser and referenced regularly as you encounter different types of security issues in your work. Thank you for your attention, and I'll see you in the next lesson.